Hello everyone, I am Sertel Kazım Solak and it is a pleasure to presenting this presentation with you today. When we gather like this, I am reminded of the power of connections and the opportunities they bring. Allow me to introduce myself and share a bit about my journey. Sorry. I am an entrepreneur and visionary and lifelong learner. I am always seeking new ways to innovate and make a positive impact on the world around me. With a background in data engineering, I have had the privilege of working on various projects and collaborating with the talented individuals from diverse backgrounds. Throughout my career, I have been driven by a passion for excellence and the determination to push the boundaries of what is possible. Whether it's building and managing successful startups, mentoring aspiring entrepreneurs, or supporting causes close to my heart, I have always strived to make a difference. You may have seen my LinkedIn profile also that I have been involved in projects related advanced visualization. This experience have not only shaped my professional journey but also reinforced my belief and transformative power of the determination, collaboration, and innovation. But beyond the awards and accomplishment, what truly motivates me is the desire to make a meaningful difference in the life of others. I am committed to using my skills and resources for the greater goods, whether it is creating jobs, supporting charitable causes, or empowering individuals to pursue their passions. As I stand before you today, I am excited about the possibilities ahead and to chance to connect with like-minded individuals who share my vision for a brighter future. Together, I believe we can overcome challenges and opportunities and create a world where innovation thrives and everyone has a chance to succeed. Let's get started with the presentation, advanced visualization techniques for complex data. And then my first slide is my introduction. Firstly, today's topics are type of the data visualization, interactive visualization, with the visualization large data set. This is the combine and the data visualization best practices. By the way, the introduction of heading, I want to give importance of benefits visualization. For example, the first heading is enhanced understand. Visual presentation of the data make complex information more accessible and understandable. Charts, graphs, maps provides and clear insights to trends, patterns and relationships within the data, allowing for the better comparison and the analysis. And the second heading is increased engagement. This means the visualizations are more engaging and memorable than the raw data and textual information. They capture attention and facilitate the communications, leading to the greater engagement and the retention of information among the audience. And the third heading, I mentioned the efficiency of the communication. So visualizations serve as a universal language that transcends the barriers such as language and expertise. They enabled efficiency communication of the couple of ideas and the facilitating collaboration and the knowledge sharing among the diverse audiences. This is the main item of the efficiency of the communication. And the fourth header is the faster insight, I think. And the visual presentation of the data enable faster insight and understanding compared to traditional data analysis methods. With an interactive visualization, user can dynamically explore the data, drill down, drill up into details, and gain real-time insights. This accelerating the decision-making process also. And the fifth heading is storytelling is the most important one, I think. For the storytelling is data visualization allows for the compelling the storyteller by the presenting data in a narrative format. Visualization helps convey the story behind the data, evoke emotions, and persuade the audiences to take action based on the insight presented. This heading is more important for the time because best practices becomes more important. So I'm going to the next slide for the types of data visualization. Pie charts and histograms, lines, area charts, Gantt charts, network diagrams, tree diagrams, scatter plots, all are the data visualization types. If you are in process of trying to build a story, persuade a group of people, or better understand your data, consider creating some sort of visual presentation to guide your truth and the truth of the others. So these visualizations type are become more important to tell this story. What is the most popular one, do you think? I'm giving no, not I am giving, bar graphs. Bar graphs and pie charts more important ones and the most popular ones of these visualization types. And the other forms, line graphs, histograms, pivot tables, box plots, scatter plots, radar charts, bubble charts, there are the others one. And so I'm going to my next slide, interactive visualization. Interactive visualization refers to use to dynamic, user-driven feature in the data visualization to facilitate exploration, analysis, and understanding of the complex data sets. Some benefits of the interactive visualization focusing on how it enables users to highlight the key insights and explore or maybe filter the data. So I will mention some important point of benefits interactive visualization. Firstly, enhanced of the engagement, I think. Interactive visualizations captive users' attentions and encourage active participation by allowing them to interact with the data in real time. It's important, I think. And the second one is the deeper understanding. Users can delve deeper into a data and gain a better understanding of the patterns, trends, and relationships by the interactive exploring different aspects of the data sets. It's important, the second important one. The third one is the customized insights, I think. Interactive visualization empower users to customize their analysis to selecting, filtering, and manipulating the data on focus on specific area or interest or relevance. And efficient communication. It is easier to communicate complex insights by allowing users to interactively explore the data and discover the key finds and their own also. And maybe users iteratively refine their analysis and hypotheses by dynamically adjusting visualization parameter, exploring alternative views, and testing different scenarios. Users also actionable decision making by the interactive visualization. For the data-driven decision, it's more important making by providing end users with actionable insights and enabling them to explore various options and outcomes interactively. Some highlights about the key insights I'm going to mention. For example, interactive visualization allows users dynamically highlighting key insights by adjusting visual elements such as color, size, shape, or opacity, and to draw attention to important data points or trends. Users annotation is important also. They can add interactively annotations and labels or tooltips and specific data points to the region of the interest to provide context and convey key insight efficiently. Focus and empathy is another feature that enable users to focus on a specific area of the data by zooming in or zooming out or panning or filtering out irrelevant information, making it easier to identify and interpret key findings. And enabling user interaction, the third section. Enabling for user interaction is exploring and filtering data. Filtering a section for the interactive visualization allow users to filter and select specific data point, category, or the time period of the interest, enabling them to focus on relevant subsets of the data. And also drill down and drill up. Users can drill and drill up into detailed data for the higher level summary or lower level summary by the interacting with the hierarchical visualization or using interactive navigation controls for this item. Sorting and ranking is the more important for the interactivity feature because it enables users to dynamically sort and rank data based on different criteria such as a value or alphabetic order or frequency or identify the top performer, outlier, or trends. And another heading is the exploratory of the analysis. Interactive visualizations support exploratory analysis by using users to dynamically change visualization type and adjust the parameter, experiment with the different views to uncover hidden patterns or relationships in the data. So interactive visualization empowers users to engage with the data in meaningful ways, enabling them to key insights and highlighting key insights, explore and filter data efficiently and derive the actionable insights and make informed decisions. This interaction visualization is the most important for the large data sets. My next slide is main focus on the presentation visualization technique for the complex data presentation. In our increasing data-driven world, the ability and make sense of vast amounts of data is paramount for informed decision making and extracting valuable insights. We should delve into various techniques that enable us to tackle the challenge of the visualizing large data sets effectively. We should to explore how these methods help us distill the complex data into meaningful presentation. For example, sampling and aggregations are foundational techniques that allow us to extract relevant insights from large data sets efficiently. By selecting a subset of data points and combining them into a summary of the statistics, we can capture the essence of the entire datasets while reducing the computational overhead. And so we should think about the reduction and the summarization of technique. These methods enable us to decrease the volume of data while retaining an essential features. Whether taught the principle of component of analysis or summarization statistics like mean, median, we can still complex data into concise representation. But what about the handling high-dimensional data? That is where the data clustering and dimensionality reduction come into play. That is where the clustering and the dimensional reduction come into play. Clustering techniques. Clustering techniques help us group similarity data points together. While dimensionality reduction method can enable us to visualization high dimensional model into lower dimensional space, this approach empowers us to explore and understand complex data structure more efficiently. And lastly, you should explore hierarchical and nested visualizations, which provide a hierarchical view of data and allow for drill-down exploration. For tree maps to nested pie charts, these visualizations offer insights into relationships and structure with the data, enhancing our understanding of complex data sets. In conclusion, visualizing large data sets requires a multifaceted approach by employing techniques such as sampling, aggregation, data reduction, clustering, dimensionality reduction, and hierarchical visualizations. You can unlock valuable insights and drive informed decision making for this. Let's talk about the main subjects of this slide. Sampling, the first one is the sampling and aggregation technique, and this is the first. Sampling involves selecting a subset of the data point from a large population to present the whole. There are various sampling techniques, each suited to different type of the data and analysis goals. Also, random sampling, for example, involve selecting data points randomly for the population, ensuring that each data point has an equal chance of being selected. This approach is useful when the population is homogeneous and there are no specific pattern or structure to consider. Stratified sampling, on the other hand, involves dividing the population into distinct strata based on certain characters. For example, this age, gender, location, and the sampling of each stratum separately. This approach ensures that each subgroup of population is adequately represented in the sample, making it useful when there are significant variation within the population. Once we have our sample, we can use aggregation technique to summarize the data and extract meaningful insights. Aggregation involves combining multiple data points into summary statistics or aggregates. Yes. For example, we can calculate the average sum or count of a certain variable within the sample to get an overall picture of its distribution or behavior. Aggregations help us to reduce the complexity of the data while preserving important trends and patterns, making it easier to analyze and interpret. And the second one is data reduction and the summarize, and this one. Data reduction technique aims to decrease the volume of that data while retaining its essential features. One common approach to data reduction is dimensionality reduction, which involves reducing the number of the variables and features in the dataset while preserving its essential structure. Principle of the component analysis is a popular dimensional reduction technique that identifies the most important axes of variation in the data and projects to a lower dimensional space. Another approach to data reduction is feature selection, which involves selecting a subset of the original features that are the most relevant to the analysis. And features selection methods can be supervised or unsupervised, depending on whether they can into account the target variable in the dataset. Once we have reduced the dimensionality of the data, we can further summarize it using various techniques, summary statistics, such as mean, median, standard deviation, and percentiles provide insights into a central tendency, spread, and distribution of the data. And histograms, box plots, and scatter plots are graphical presentation that visualize the distribution of the data and help identify outlier trends and the patterns for the data reduction and the summarization. And the third one is using data clustering and the dimensionality reduction. Data clustering techniques group similar data points together based on their features and attributes. Clustering helps us identify natural patterns and structures within the data, such as cluster of the customer with familiar buying behavior, for example, or clusters of the genes are similar expression profiles. There are various clustering algorithms, including k-means clustering, hierarchical clustering, and density-based clustering, each suited to different type of the data and the analysis goals. Dimensionality reduction technique transforms high dimensional data into a lower dimensional representations while preserving its essential structure. These techniques are particularly useful for visualizing high-dimensional data in 2 or 3 dimensions, making it easier to explore and interpret complex data sets. And the fourth one, hierarchical and nested visualization. This represents data in a hierarchical structure where elements are organized into a parent-child relationship. This visualization provides a natural way to explore hierarchical data structures, such as organizational hierarchy and maybe listed categories or taxonomies also. Tree maps, sunburst charts, and dendrograms plots are examples of the hierarchical visualization that help us visualizing the relationships between different levels of the hierarchy and identity pattern, and also structure within the data. Nested visualizations display the data within multiple layers of the nested structures, allowing users to explore relationships at the different level and the different granularity. These visualizations provide a hierarchical view of the data while enabling drill down and drill up exploration. Nested pie charts, nested bar charts, and nested tree maps are the example of the nested visualizations that help us visualizing the complex data structure and uncover insights at the different level of the abstraction. This is the nested visualization highlights I mentioned. I am going to go the next slide also, and the data visualization best practices. The first heading is know your audience. This is an important one. Understand who will be viewing your visualization and tailor them to their level of expertise, interest, and preferences. This is important for visualization, for best practice, because you must know your audiences. And the second one is choose a right visualization. Right visualization tool, right visualization technique is much more important after the audience. Selective the visualization that efficiently communicate your message and highlight the pattern and trends in your data. Consider factors such as the data type and the message you want to convey to the audience's familiarity with the different visualization types is the best choice. And the third one, tell a story interactively and structure your visualization to do this story in a way that tells a clear and compelling story. Use a logical flow maybe and narrative arc and to guide viewers through the data, and highlighting key insights also important, and trends along the way also. And the fourth one is simplify and clarify, and please keep your visualization simple and focused. This is avoiding a cluster and unnecessary elements. Use clear labels, the titles, and annotations to help viewers interpret the data accurately. And the conclusion of my presentation. My presentation is about me. At the end of my presentation, I have a key takeaways. This is so important. Firstly, clear data for good information, this one. And second, storytelling for the best concept. And the third one is goal, for more functionality, for the more function based. And the third one is visual form for metaphor, for the best metaphor. These items are the sine qua non of the successful data visualization narratives. Be aware of these items. As I conclude our presentation of advanced visualization techniques, it is important to recognize that our journey is ongoing. With the knowledge and insights gained, let us persist in pushing the boundaries of the achievable, utilizing visualization to unlock the full potential of complex datasets. I extend my sincere gratitude for engagement and attention throughout this presentation, and have a wonderful day. Goodbye. Thank you.